28,000 tons of steel. A submarine longer than 2 football fields, worth $9 billion. The USS District of Columbia sits ready for its first taste of water. One wrong move during launch could destroy America's most advanced nuclear submarine in seconds. The pressure is enormous. The stakes couldn't be higher. And in just moments, this massive war machine will slide into the ocean using methods that blend centuries-old traditions with cutting-edge engineering. This is how the US Navy launches its deadliest submarines. The moment a submarine touches water for the first time marks the birth of one of America's most powerful weapons. But getting these massive vessels from the shipyard into the ocean requires precision, planning, and nerves of steel. Behind the scenes at General Dynamics Electric Boat in Connecticut and Newport News Shipbuilding in Virginia, America's finest engineers and craftsmen work around the clock. They're building the most advanced submarines on Earth. The Virginia-class attack submarines, the massive Columbia-class ballistic missile boats. Each one costs billions. Each one takes years to complete. But all that work means nothing if the launch goes wrong. A failed submarine launch can destroy years of progress in seconds. The engineering challenges are staggering. The risks are real. Yet somehow, American shipbuilders have mastered this dangerous dance between man and machine. If you're proud of American naval engineering, type proud in the comments below. Today, we're taking you inside the most secretive and spectacular process in naval construction. You'll discover the 3 main methods the US Navy uses to launch submarines. You'll see how a single mistake during launch nearly sank a luxury liner. And you'll learn why America's submarine builders are racing against time to meet the demands of a changing world. The scale of modern submarine construction. The numbers are mind-blowing. The Columbia-class submarine stretches 560 feet long. That's longer than the Washington Monument is tall. It displaces over 20,000 tons when submerged. To put that in perspective, that's heavier than the Statue of Liberty, pedestal and all, but size is just the beginning. These submarines carry 16 Trident ballistic missiles. Each missile can strike targets thousands of miles away. The reactor that powers these boats will run for 42 years without refueling. That's longer than most people work in their entire careers. Building one of these submarines takes nearly a decade. Thousands of workers contribute their skills. The hull alone requires steel plates so thick they could stop a tank round. The precision needed is incredible. Parts must fit together with tolerances tighter than a human hair. The Virginia-class attack submarines are smaller but no less impressive. At 377 feet long, they're still massive. Each one costs $2.7 billion. They can dive deeper than Most skyscrapers are tall. They can stay underwater for months without surfacing. Right now, America has 2 main shipyards building these underwater giants: General Dynamics Electric Boat in Groton, Connecticut, and Newport News Shipbuilding in Virginia. These aren't just shipyards, they're American manufacturing powerhouses. Electric Boat employs over 24,000 people. Newport News isn't far behind. But here's what makes this even more remarkable. These 2 companies used to be fierce rivals. They competed for every contract. They guarded their secrets jealously. Today, they work together as a team. Electric Boat handles final assembly. Newport News builds the bows, sterns, and sail sections. This partnership represents one of the greatest success stories in American defense manufacturing. The coordination required is staggering. Newport News builds submarine sections in Virginia. They load them onto massive barges. Those barges travel hundreds of miles up the coast to Connecticut. There, Electric Boat's teams fit everything together like pieces of a giant puzzle. One delay at either yard can throw off the entire schedule. Method 1. Dry dock, float out. The safest way to launch a submarine is also the most spectacular. The dry dock float out method turns launching into a carefully controlled ballet of engineering precision. The process starts with an empty concrete basin. Workers build the submarine inside this giant bathtub. The basin sits below the waterline, but massive gates keep the ocean out. For months or even years, the submarine takes shape in this dry environment. Workers can access every part of the hull. They can work in perfect conditions regardless of weather or tides. But the real magic happens on launch day. The submarine sits complete in the dry dock. Engineers have calculated everything down to the last detail. The weight distribution, the center of gravity, the exact amount of water needed. There's no room for error. The launch begins when workers open the sea gates. Water rushes into the dry dock with tremendous force. But this isn't a flood. It's a precisely controlled filling process. Pumps regulate the flow. Engineers monitor water levels constantly. The submarine must remain stable as it begins to float. As water rises around the hull, something amazing happens. Tons of steel begin to float. The submarine's weight seems to disappear. It's supported entirely by the water beneath it. This moment when a submarine first achieves buoyancy is called first float. For shipbuilders, it's one of the most exciting moments in the construction process. The USS Gerald R. Ford aircraft carrier used this method. So did many of the latest Columbia-class submarines. The float-out method is gentle on the submarine's hull. There are no sudden impacts, no dramatic splashes, just a smooth transition from land to sea. But gentle doesn't mean simple. The timing must be perfect. Engineers coordinate with tide tables. Weather forecasts matter. Even the moon's phase affects water levels. A difference of just a few inches can mean the difference between success and disaster. Once the submarine floats freely, tugboats move in. They guide the new vessel out of the dry dock and into open water. From there, the submarine heads to a fitting-out pier. This is where crews install the final systems. Electronics, weapons, life support equipment, everything needed to transform a floating hull into a fighting machine. The dry dock method requires enormous initial investment. Building these concrete basins costs hundreds of millions of dollars. But for the largest submarines, it's often the only practical option. You simply can't slide a 560-foot submarine down a traditional slipway. Method 2. Traditional slipway launch. The slipway launch is where tradition meets modern engineering. This method has launched ships for over 1,000 years. Yet today's submarine launches use the same basic principles that sent Viking longships into the water. The process begins long before the submarine is complete. Workers build a slipway, essentially a reinforced ramp leading into the water. The angle matters enormously. Too steep, and the submarine hits the water too hard. Too shallow, and it might not reach deep water. Most submarine slipways slope at about 1 inch for every 20 inches of length. The submarine sits on this slipway, supported by a cradle. This isn't just any cradle. It's a precisely engineered structure that matches the submarine's hull perfectly. The cradle distributes the submarine's weight evenly. Any weak points could cause the hull to crack under its own weight. The real engineering challenge comes with the ways. These are long wooden or steel rails that run down the slipway. Workers coat them with grease. In the old days, they used tallow and whale oil. Today, they use modern lubricants that reduce friction to almost nothing. Launch day is theater and engineering combined. Hundreds of people gather to watch. The submarine's sponsor, always a woman in U.S. Navy tradition, steps forward. She holds a bottle of champagne. The words are always the same. "In the name of the United States, I christen thee." The bottle smashes against the hull, but the real drama happens next. Workers remove the triggers that hold the submarine in place. These triggers are designed to fail at exactly the right moment. Sometimes they're cut with an axe. Sometimes they're released electronically from a ceremonial platform. Gravity takes over. The submarine begins to slide backward down the slipway. This isn't a gentle process. The submarine accelerates as it slides. By the time it hits the water, it's moving fast. The splash can be enormous. Spectators sometimes get soaked from hundreds of feet away. The USS Colorado used this method when it launched in 2016. Annie Mabus, daughter of the Navy Secretary, smashed a bottle of Colorado wine against the hull. The submarine slid backward into the Thames River at Electric Boat's Connecticut facility. The entire process took less than a minute from trigger release to the submarine floating free. But speed creates risks. The submarine must be strong enough to handle the stresses of launch. The hull experiences forces it will never face again in its operational life. The impact with water is violent. Engineers must calculate everything perfectly. Too much speed, and the submarine could dive too deep and not resurface. Too little speed, and it might get stuck on the slipway. The moment of water entry is critical. The submarine's stern hits first. Water rushes around the hull. The bow lifts into the air before crashing down. For a few seconds, the submarine rocks wildly. Then stability systems take over. The submarine settles into its natural floating position. Drag chains sometimes slow the submarine's entry. These chains trail behind the submarine as it launches. They create resistance that prevents the submarine from hitting the opposite bank of the river or striking other vessels. Managing this process requires split-second timing and years of experience. The human element and traditions. Behind every submarine launch stands an army of skilled Americans. These aren't just workers, they're craftsmen carrying on traditions that stretch back generations. Many families have worked in these shipyards for decades. Fathers pass skills to sons, mothers train daughters. The knowledge accumulates over time. The sponsored tradition remains powerful. Every U.S. Navy submarine has a female sponsor. She's chosen for her connection to the submarine's name or mission. The sponsor doesn't just break the champagne bottle. She maintains a relationship with the submarine throughout its service life. She attends major events. She corresponds with the crew. She becomes part of the submarine's extended family. Champagne became the traditional christening fluid in the 1890s. Before that, ships were blessed with water or wine. During Prohibition, some submarines were christened with water or cider. The submarine V6 was famously christened with apple cider. But champagne returned after Prohibition ended. Today, it's exclusively American sparkling wine. The bottle breaking carries deep meaning. A bottle that doesn't break on the first try is considered bad luck. Workers sometimes score the bottle beforehand to ensure it breaks cleanly. But the tradition remains powerful. No U.S. Navy submarine has ever been launched without this ceremony. Workers take enormous pride in their craft. Building a submarine requires hundreds of specialized skills. Welders who can work in impossible positions. Electricians who understand nuclear systems, painters who can work inside narrow spaces. Each trade contributes essential skills to the final product. The launch represents the culmination of years of work. For many workers, it's an emotional moment. They've poured their expertise into creating something that will serve America for decades. Seeing their submarine take to the water for the first time is deeply satisfying. Current challenges and innovations. America's submarine builders face unprecedented challenges. The demand for submarines is rising faster than the ability to build them. The Navy needs submarines to counter growing threats around the world, but building submarines takes time, lots of time. Currently, America's two main shipyards deliver about 1.3 submarines per year combined. That's not enough. The Navy needs 2.3 submarines per year to meet all its commitments. This includes submarines for the AUKUS partnership with Australia and the United Kingdom. American yards must nearly double their production rate. Workforce shortages create the biggest bottleneck. Building submarines requires highly skilled workers. Training someone to weld nuclear submarine hulls takes years. The knowledge can't be rushed. Yet both Electric Boat and Newport News struggle to find enough qualified workers. Supply chain problems make everything worse. Critical components arrive late. Northrop Grumman builds the turbines that convert reactor steam into electricity. These turbines are months behind schedule. Newport News builds bow and stern sections. They're struggling to keep up with demand. Every delay in one area affects the entire program. The COVID-19 pandemic exposed these vulnerabilities. Shipyards had to implement social distancing. Worker productivity dropped. Suppliers struggled with their own challenges. The effects are still rippling through the system years later. But American ingenuity is finding solutions. Newport News recently bought a manufacturing facility in South Carolina. This will allow them to build submarine modules closer to their suppliers. Electric Boat is investing in new facilities and equipment. Both companies are raising wages to attract workers. New technologies are helping too. Advanced computer modeling reduces design time. Robotic welding improves consistency. Virtual reality training gets workers up to speed faster. These innovations won't solve every problem, but they're making a difference. The urgency is real. China is building submarines rapidly. Russia continues modernizing its submarine fleet. America's undersea advantage depends on maintaining the highest quality while increasing production speed. Conclusion. From the massive Columbia-class ballistic missile submarines to the versatile Virginia-class attack boats, America's submarine builders continue pushing the boundaries of what's possible. Each launch represents thousands of hours of skilled American labor. Each submarine carries the hopes and security of our nation. The methods may vary, dry dock float-out, traditional slipway, but the goal remains constant, getting America's most advanced submarines safely into the water where they belong, protecting our nation and our allies around the world. These launches represent more than just moving steel from land to sea. They demonstrate American industrial capability. They showcase the skills of American workers. They prove that when challenged, American engineering and manufacturing can deliver the impossible. The next time you see a submarine launch, remember the years of planning behind it, the thousands of skilled hands that built it, the traditions that guide it, and the sacred mission it will carry as it disappears beneath the waves. Thanks for watching this deep dive into America's submarine launches. Hit that like button if you're proud of American naval engineering, and subscribe for more content about the forces that keep America safe. Until next time, keep supporting the red, white, and blue.